Let's talk about what do we want to do for this episode? Do you have a? I was like, we just came up out of nowhere last time. So, have you had any thoughts today of, or this week of like what would be a good episode topic?
Hmm. Well, the kind of to go with the example you were giving previously before we recorded last time, uh, have you run into situations where not only is your code your issue, but the hardware is the issue? Like you're not actually configuring the hardware for your application?
Oh, geez, I've been like that was yesterday. That was half my day. It wasn't. It was. It's frustrating. So I've put together um, Apache front ends to Django now a couple of times, and it's it's always a little bit different because it like if you do a Debian versus um, and I forget what the core like, but yeah, if you use like apt-get versus yum versus Mac, and I haven't even tried Windows, nor do I, I did like decades back and don't want to ever touch it again. They're all different. They're all like close, but not quite. And so you have to like go find the right library and the right download and the right all this stuff. And I was working on a machine that I thought was one, and I got and realized, oh wait, it's different. But it's like it's a whole thing that I'm setting up because I'm setting up Apache, which I got that, that was fine. But I'm setting up Apache, I'm setting up SSH or SSL stuff. I'm using certbot, so I'm grabbing a cert and I'm trying to make sure that I've got like that hooked up so that it grabs the right certificate, and then making sure I've got the files in the right place, that it handles port HTTP as well as HTTPS, and it's connecting to everything, and that it's all routing right. And it's just a bunch of stuff that's like very sensitive. Got to be got to be the exact right name. Names have got to match right and everything. And I wasn't able to do it in one sitting. I got something done, got pulled away. Got something else done, pulled away. And so it just took forever because every time I sat down, I had to had to remember where I was at, and then two, had to like go track this down. And there's three or four different log files I'm looking for. So short story long, yes, I have definitely run into that a couple of times. Configuration is if I could do software and never configure anything ever again in my life, even my own software, I think I would be happy because I get bit by my own configuration settings on a regular basis. Where it's like I built it like an app I was testing today. I was like, why is that not working? It's like, oh yeah, we've got this configuration setting and we didn't set it right. It's like we adjusted it. All right, let's set it back, and then boom, everything works again.
And seeing on the flip side of that with the testing stuff, when you want to do like load testing or high-end regression testing, you need to run your tests multi-threaded. Well, in order to do that, you need a certain amount of CPU and you need a certain amount of RAM in order to be able to keep up with that load. It's not necessarily always about memory leaks or things like that. If you are trying to push high volume, you need to have the resources to push it. And that was one of the things I was running down today is we tested all of our production code in QA at high volume for generating reports, and I had it all working. Everything worked for every use case we had. Now it's in production, and what I didn't know is that we've been kicking up the memory in production. We're up to like 16 gigs, and we're still running out of memory with our largest, with one of our largest vendors that has over 2 million records. Come to find out, we're only running four core processor with 16 gigs of RAM. So I actually, one of the cool things about Spring Boot and Eclipse, you can actually configure your profiler for the specific cores and memory you want to run. So I've got a 12 core laptop with 64 gigs of RAM, so I can actually do pretty much whatever I want locally without even needing to do containers, or I could just stand up a container or whatever. But what essentially I ran into is I clicked run locally. I mean, I'm running all of our applications locally. We're all microservices distributed, but I have it all locally. Clicked run, ran fine. Use case worked. Report got generated, no problem. I'm like, all right, what the hell's wrong? And then I started getting into it. I'm like, well, let me go look at production. Finally got back into production because I found out AWS for some reason defaulted to a different region for me. So while I'm able to log in, I had no servers. I had no. I'm like, where the hell's all my stuff? That was a fun hour. Uh,
I
but
have lost that hour myself a couple of times.
But anyway, once I got in there, though, I walked into the deployment and looked at the setup and found out, okay, we've got 4 cores and 16 RAM. So I went into JVM and I configured it to 4 gigs of RAM. And it was cool because I found out with the JVM, you can, with any Eclipse, you can do like available cores or available system. I forget the exact name. It's not the same as you would for Maven. It's a different property VM, but you can actually set the cores. So then I used Visual VM, Visual VM to profile the memory because we used that before in the past. It's a cool little free profiler. And I spun it up. I watched things go. And before I had this nice flat line with my 12 cores, with all my memory, it barely got above like 4 gigs of RAM. Under 4 cores and 16 gigs of RAM, or I did 4 cores and I did 4 gigs of RAM to start with. So I did 4 to 4. And immediately I watched the spike go from this to this. And within like 30 seconds, I'm out of memory. So I'm like, okay, that was interesting. So then I flipped it back to 12 core, still ran out of memory, but I was able to get it up to 6 gigs of RAM and it worked. So I slowly then started rolling back the processors and essentially I got it down to 8 and 8. So if you have 8 cores with 8 gigs of RAM, it worked. Now my boss is like, well, we need to go look at the code. We have a memory leak. I don't think so. I think trying to process 2 million records in memory at once because we're sorting them, we're doing manipulations with that's a lot of processing power. It's not just memory. We're trying to do stuff with that. If we were just holding it in memory, sure, I would say we have a memory leak, but no, we're constantly like resorting the list. We're building spreadsheets with this. I don't think it's necessarily a memory leak as it's a processor leak. We need more processing power. Anyway, this was kind of this discussion I thought would be good for the podcast, which we're now like way
I think so. I think we can.
Stuff.
Well, we're gonna, yeah. I think we can go into some of this stuff. It's just some like common oddity type things that we've run into, and I've got some similar types of experiences that I can talk about a little bit, and sort of like what some of it's like thresholds and stuff like that, and sort of tackling those a little bit, and then I'll toss it over to you, and then you can probably rehash some of that. So those of you guys that are listening, sorry you may hear this twice, but we don't remember what we said, so it'll be a little bit different anyway. So there may be something more ingenious on that second side around. Well, hello and welcome back. I'm sorry, I didn't mean to smack too close to the mic, but that happens sometimes. We are back with Building Better Developers, yet another episode where we're talking about stuff that we've run into. This episode, we're going to go a little bit, some of it's very current for Michael, some of it's not so much for me, but some of the things that I've hit in the past. And it gets into like debugging stuff when you get away from, it's like not just code, it's hardware issues. And it literally is like memory and resource issues and things like that, which you may not run into as much depending on what your applications are. Because these days there's a lot of stuff that is very much plays well within the norms. But if you start doing big data, if you start doing data processing, if you've got an app that's got a lot of users or a lot of processing, a lot of data, any of that's a lot of stuff going on, things can happen. So we're going to talk about that. First, I'm going to introduce myself. My name is Rob Broadhead. I'm one of the founders of Developreneur. I'm also a founder of RB Consulting, all things about simplifying, integrating, and just automating your software, your solutions to make your business run smoother. On the other side, this time I'm not even going to mention his name. I'm going to let him do the whole introduction. So go for it, sir.
Hey everyone, my name is Michael Malash. I'm another co-founder of Developreneur. I'm also the founder of Envision QA, where we build custom software for small to mid-sized businesses and healthcare clinicians. We also offer consulting services and testing services for your needs.
Awesome. Now we're going to get right into one of those cases where you may need some of those testing services. And particularly it is with like the big behemoth of stuff that we can sometimes run into in the software world is the hardware stuff, the resources that are related to like processing and the ones related to, well, and storage and memory. Now, the fun ones are when storage and memory cross lines. And this is where you see some really neat stuff. And these are the kinds of things that it's just, we're going to give you some like, they're not, I don't know if they're necessarily red flags, but there's some things that are maybe some notes that if you are in a testing situation or in a situation where, hey, it works on my machine or usually, and now it doesn't, and the code should be the same, when you get a sense like that doesn't make sense, it's not a different system. Here's some things to go look at. Maybe there's something going on that's a little deeper than that, where you're going to want to have some sort of, some more detailed logging, particularly from the operating system side, the platform side, to see what is actually going on. Now, one of the mother of all break your application things that happens is when you trigger, when you get past physical memory and it starts to cache stuff. Because what happens is now you've got physical memory that's just like really, it's like boom, 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 boom. Now it's gotten better because SSD drives and some of that stuff is very fast, and there's a lot of intelligence built around those things often so that you can, so it's going to keep the most recent data like up front. So if you have something that, if you're caching your memory, the system memory, into like an SSD drive or really high speed drive, you may not notice the difference as much, but definitely if you're old school and you go to one of the old, disk driven type hard drives, the processing speed goes from microseconds to multi-seconds. And it literally, I don't know how many times it was stuff where it's like, I've just picking up, like let's say we have 2 gig of memory on our machine, and everything was awesome until we had it grow beyond 2 gig, because as soon as it did that, it had to swap stuff out. And now you have the swap cost. So now it's pushing stuff out to that hard drive and then having to pull stuff back. And that's adding some processing time. And then it just sort of like feeds on top of itself. Now in a real world, what you will often see is that really spirals out of control, because what you have is people are pulling reports and they're expecting reports to come, let's say, picking up every 10 seconds. They should be able to get the report back and see their data. And what happens is people get impatient. So when it triggers that, and so now it goes from 10 to say 15 seconds, people hit report again. And so there are times I've seen it's like, if you don't have intelligence around that, then it'll be, I just created 8 instances of trying to run this report that is doing table scans. And if you don't know what that is, go look it up and realize that's something that you should never do. But it's maybe doing table scans, and the next thing you know, it's like your time has gone from 10 seconds to 10 hours. And it, like, everybody freaks out. Everybody panics. It's somewhat reasonable, but it's like, hey, just chill. All we need to do is make sure that we don't hit that limit. Or sometimes it's just a matter of like, hey, let's clean up our queries a little bit, or what we cache or what we store. Now, sometimes that's harder than others. Sometimes the easiest way is to just like slap a bunch of hardware on it and say, boom, we're going to get more memory, we're going to get more processors, and we'll take care of it that way. But honestly, it is safer, better, and more reliable to fix it in the software, in the code itself, to do the software fix. Now, sometimes that means rewriting. And so I'm going to give one more thing that I've run into in the past before I toss it back over to that guy I didn't name earlier. And that is, sometimes you want to change, and this goes into like being a better developer. You want to change your approach or your format, what you're doing completely. The framework, it could even be the foundation of what you're doing. And a good example of this for me is I was working for a company many years ago, and they were doing these very large ACH files, which is basically just a lot of fixed length data that's coming across. We're talking hundreds of thousands of records. And I was hitting this problem is that I originally had like a nice little, I think it was a Java application that would just pull this thing in, spin through it really fast, and kick it back out and did what it needed. I was storing it out to a database. It just stored it out to the database. Cool. And it was doing all the manipulations and everything. Well, once it got to a certain size, what happened is it was sucking too much of the file in, and then it ran out of memory, and then we started running into problems. Now I'd switched it. First thing I did, I was like, okay, let's try to do this differently. So it was like pulling a line at a time. I was like, okay, well, we're just going to process. We're not going to have the whole file in. We're just going to have a pointer. We're going to move through. Still ended up with problems because what we're having to do is actually read data and then refer to other data. And so there was a lot of relational things that we had to deal with within the data. So that to me was a clue that what if we try a relational database? And what I ended up finding out was that if I use, and this was just using MySQL, I think it was MySQL, it may have been Postgres. It was one of those where I used their import, it was a stored procedure that allowed you to read from a file. And so what I did is I would read from the file, create a temporary table, shove all that stuff in the table, do a bunch of manipulations with it, and then peel it back out. I think I was even creating indexes on the fly. So I would pull it in, index certain things, basically do a big, some mass updates, and then re-pull it back out. And I went from hours to less than 30 seconds to run through this stuff. And it was because the tool that I had originally thought I was going to use and worked fine to a certain extent. And then it was limited. After that, it ain't going to work. And I ended up rewriting it and went a lot better. And that is why more of the story is make sure that you don't get stuck in a single technology, a single solution, or just insist that whatever you're writing is the way to do it until you've verified that. So that's my little nugget for the day. Let's toss this back over to you.
So I'm going to take it a different direction. So you talked more single system based, talking about writing your code, doing the database side of things, moving it to the data, moving the file import to the database. So it's kind of a paradigm shift, or moving the load essentially to a different location. Now, in today's world, we hear a lot about distributed systems. We hear a lot about micro applications, microsystems. And as we break things down smaller into their smaller components, and we break these out into different applications, APIs, deployments, S3 with Amazon, message queues, there's a whole lot of different systems out there that we have to integrate with, and it can actually mask a lot of the problems that we potentially have, either with our code, with the configurations we have that for these systems that are deployed. And it's rather interesting. So I'm going to tell you a story of a situation I was in a couple of years ago. And the application I inherited when I became a manager of this team, I found out that we had essentially our core application was on fire. It literally went down once a day or 2 to 3 times a day. This is a healthcare application. This is actually pulling healthcare information in from external systems into our system. So this could actually impact patients' lives. So we needed to come up with a way. One, we had to figure out why it was going down so much. And the very first thing we had to look at was, is it our code? Well, the system that was crashing was called Rhapsody. And we found out that it's essentially just a message queue that's pulling information in and passing it over to us. Yes, it did some things on its side, but it was essentially being just used as a pass-through. So as we were looking at that, we literally had just taken out all of the logic and just moved message in, message out. So we would just pass it over. It still kept crashing. So we literally just moved it down to one process. So it did one thing. We still were essentially going down because of volume. So the other thing we looked at was, okay, what is our network threshold? Are we just essentially having too much information coming in and it's a big pipe over here and a small pipe over here? And that was part of it. So we did increase the output flow through the network. So we had more data going out than we did initially. And then we essentially found out that we were running on a machine that had two core processes, maybe 4 gigs of RAM, and it was nowhere near enough to handle the amount of data that we were consuming. The other thing that no one happened to think about was how much disk space we had. Because of the large volume that was coming in, we were actually running out of disk space on top of the memory issues, on top of the CPU issues. So it's not always your applications. It could essentially be that the system that this was built for has aged out to the point that you need to upgrade the hardware that's the backbone of the system. So that was one story. The second story is now in a more distributed environment with AWS, we have lots of applications all over the place. And with the microsystem approach, you typically want to rate your application to be very small, to consume a very small amount of resources, so it'll run on a very small build or AWS like EC2 instance or Windows instance or something like that. So the smaller instance that you can deploy to, the less money it's going to cost to keep that application up and running. The problem with that potentially is you could scale very small. Your application works initially, but then again, you could run into that situation like we did with the Rhapsody system, where the load of the application or the application is essentially outgrown its hardware. It's outgrown the container that it's being deployed to. Recently, I ran into a situation where to address this, they were essentially just kicking up the memory of our container, thinking that, oh, we needed more memory to keep working, to keep things happy. Well, at 16 gigs, we're still going down for one particular transaction that goes through. Doing some research, like we've talked about before. So this is one of those situations where the customer does one thing, it breaks. We, as the developers, do something, the same thing, literally the same thing, and it works. So now it's like, okay, what is different between the two environments? Well, as developers, we typically have these supercomputers or very beefy machines that can do just about anything that we want it to do. But again, we're deploying to containers that are meant to be very small, take up a lot less resources, so they cost less money. Ideally, what I found out was we underpowered our container to the point that we were doing so many transactions, so much work behind the scenes, that we essentially just need more CPUs, not more memory. So this is one of those situations where you need to understand what the CPU is used for versus the amount of memory. Yes, we had a lot of data in memory, but we're doing a lot of transactions with that. So you actually need more CPU power than memory, because if you try to keep all that in memory, you're going to get an imbalance and things are going to crash. However, the potential you could still have a memory leak. So what you're going to want to do is you're going to want to get things like profilers to go monitor your code as they're running, and then look for things like heap dumps or objects in memory or memory spikes when you're doing transactions within your code. So you can not just check the hardware and the physical hardware, but you still can check your code to make sure that you don't have runaway code. You don't have like an infinite loop that's just eating out memory and you never know what happens. So Rob, I'll pass it back over to you.
I'll give you two little quick ones too that on top of the both that you reminded me as you were going through this. One is hard drive space. It used to be like, I don't know, back in the old days, you used to always find code somewhere along the way that was saying, hey, is there enough hard drive space? Like I remember going to this is back like the old 386 DOS days where like every little app that you did, one of the first things it would do would be, do you have enough hard drive space on it? And that still exists, but not to the same level. In particular, server applications. There's a lot of times that they don't think about it because they don't care. They're like, hey, I'm just going to run. But things like log files in particular can two things actually. Log files, I've found several times that those got huge, and those sucked up the all of the data for. I actually have a little miniature. Same thing. I had a little VM app or a little small EC2 app, and it blew up because the log got too big, and it crashed the whole system. And I've also seen it when you've got upload files. If you have the ability for users to upload stuff, if they can upload huge images or videos, or if that's part of it, then you need to make sure that that is a constant check that you have in some way, form, or fashion to make sure that you have enough space if you store it, actually, if you store it locally, but also if you temporarily store it locally to make sure that those are getting cleaned out. Because I've seen some situations where it's using S3 or something like that. So it's moving stuff off, but sometimes it doesn't move it off fast enough or clean enough. And the next thing you know, you've blown that up. The other thing that you can run into, I just forgot, but it's log files, and I now forgot the other one that I have run into. Oh, I'm sorry. The other one is the debugger itself. I have run into situations where if you put something into debug mode, then it causes issues in itself because it's eating up extra processing and extra time. And so I have actually seen situations where the application goes into production and it breaks because somebody left the debug flag on, or it's not useful because they've got it in debug mode. So when you push it to production, clean it up. Like shut that stuff off. Like make sure that you've got your settings such that it's not like just dumping a whole bunch of debug information to a drive somewhere if you don't need it. So don't be afraid to like have some flags or settings or something so that it only does that when you want it to, which is basically you as a developer. You want to see all that stuff. Nobody else does. But, final thoughts on that?
Yeah, the other things we kind of talked about them, but we didn't really address the resource things. But in this distributed world we live in, we have things like databases, we have in-memory databases, we have message queues, we have S3 for external data sources. As developers, as we write our applications, unfortunately we're kind of siloed. We kind of see our picture, our problem that we're solving, and we know we have these resources, we use these resources, but we don't consciously take into account what is my code change going to do to the rest of the ecosystem. So typically you kind of throw it over the wall and let someone else deal with it, and you don't think about it. But sometimes you really need to you need to understand how that ecosystem works so that as you're writing your code, if something does happen, you have a better idea of where to go within the structure to debug the problem. Also, you don't want to necessarily fill up someone's database by leaving those log files on and have, make someone else's day miserable because they're not necessarily in your department. You don't want to really make your sysop guys mad.
So one other bonus that I just thought of while you were going through that is don't assume, unless you can, don't assume that your app is always going to run in a connected state. In particular, one of the things that I'm early on when I was I would do some development stuff and I would have some things break periodically and I'd be like, wow, like that website I'm bringing up looks horrible. And what it was is because I was just, instead of having some of those like say like CSS files and things like that we like to grab local, they were on some CDN somewhere else and they were pulling it down. And so if I wasn't connected, nor were those. And so you would suddenly have like you'll have libraries and stuff like that they're not available because you're normally pulling those off the internet. This also, and this even if you're a web application, so you assume that the only way people are going to get to it is if the internet exists and it's working. Don't be afraid to pull, and I would say don't be afraid, but just like the smart person, the wise man pulls those things locally, because if that CDN goes down or that site that you're borrowing that from or you're connecting to or that you're relying on goes down, you are down. So the more you can bring that stuff in and make it, so that if your site's up, it's up, and if it's not, it's not, and you have less other places that you're relying on, then it's just going to be that much better. However, if you rely on us, do that. Just like double down on it. Rely on us. Check us out. Like subscribe 6 different ways. Subscribe on your phone, on your laptop, on your watch, whatever it is, because we're going to give you good stuff. And if we don't, that's your fault because you didn't tell us at info@developreneur.com or developreneur.com. Fill out a contact form and let us know what is the good stuff that you want us to talk about. How can we help you out? Because we're happy to help you out this way to just like, as you can see, we are an endless well of full of just mistakes and issues and all kinds of problems you can run into. But we might have a couple that, be more than happy for you to suggest something so that we can make sure that it's much more applicable to you. Yes, you right there, that you're the one I'm talking to, not the one next to you. Don't look behind you. You're the one that can help us out. And then we get to talk to you specifically and say, here's your problem. And we may even use your name if you want us to, or we'll use a really cool fake name if you want us to do that. Those are just some of the services we have to offer. That being said, it is time to wrap this one up. We got to go. We got to run. So do you. So go out there and have yourself a great day, a great week, and we will talk to you next time. Deep breath, cleansing sigh. All right. Any bonus material you want to throw out on this one?
I not necessarily bonus, but just kind of like a historical thing. So I just read an article that I guess DOS is now open source, so you can now go get DOS and reinstall it again and play around with it. I remember back in the day, I mean, we're talking true DOS, Dr. DOS, before Windows 3.1. If you wanted to install a mouse, you had to configure your system to move the mouse into upper memory. You had lower memory. You actually had to figure out, okay, how many bits, how many bytes do I need to put this here and there? What do I need? So for those of you that are maybe the last decade in software, you didn't have to deal with this. We literally had to look and count how many bits and bytes we could actually put in certain places in memory. Now, today it's a lot easier. However, still with JVMs, with compilers, things like that, you still need to be conscious of this. Maybe not as bad, but still, hardware is expensive. Even though AWS makes life a lot simpler with the resource sharing it does, just be mindful of that. If you have something that can probably run on, half a CPU, maybe 100 megs of memory, run it that way. Don't kill yourself. But just be conscious of that. Don't spin up something that's 8 gigs, 8 core for something that you don't need.
Yeah, that's funny because I remember we had a PC Junior and we're going to get a mouse for it, and the mouse came with a memory expansion card so that you could jack it up to 128K, not meg, but K of RAM, because it needed it. You had to have that to be able to load the drivers. So they're like, you know what, we're just going to bundle the memory with it. And I can't remember. I want to say that we ended up got it and just used it for the memory as opposed to the mouse. The mouse was there, but like almost nothing used the mouse because
it was all command line. Yeah.
Yeah. I think I had like one, like it was PC Magazine or something like that. I don't remember if that was the one that like had code periodically. So there was a basic app that was like, here's the code. It was like 500 lines of code to do a little like game of some sort. And it included code to access the mouse and be able to do some stuff. So that was the first thing where I was like, I remember like sitting there and copying it off because you couldn't copy and paste. I had to like sit there and type all of it, reading from the thing, run the whole thing. And I was like, oh, look, I'm using a mouse. And now it's, gone way beyond that. But
I mean, even before that, my first computer was the Commodore VIC-20. So if we wanted memory, we had to buy a 64K cartridge that plugged into the back of our keyboard. And we had the tape drive. So the only way you could load stuff into memory was to essentially play it from a cassette tape, record it to a cassette tape, and play it that way. One last thing, in the video game realm, when the Sega Saturn came out, with actual memory cards that you could plug into the system's memory card so that you could actually play larger games. So they kind of had an external jack that you could plug in extra memory so you could play more games without having to open up the system and install new hardware. So it was kind of a cool little tidbit there.
And some of those things haven't changed. You still, if you get, depending on what you get, you can get all these little like memory plugins and stuff like that, and storage plugins. So they're always going to find ways to like charge you a few extra bucks based on your stuff. Oh, by the way, just totally random because we mentioned games, bonus stuff. Apparently PS5s are readily available because I had to go by Best Buy to replace something the other day, and they had a wall just full of them. And so after what has been like 2 years, and maybe it happened a month or two ago, but I know for the longest time you couldn't find a PS5 hardly anywhere. It's like if you found one, you needed to buy it right there because you weren't going to see one again. And I know I think that's how you got one. I know both my kids that have them, that's what they did. They were just like, one was in a Walmart and it was like, just happened to find it. It's like, well, I wasn't going to buy a PS5 today, but I saw it, had to buy it. But now apparently they're readily available. So if that's something you want, go out and grab yourself one before they become scarce again, which probably don't have to worry until they come out with the PS6, in which case that'll take you 3 or 4 years to be able to get your first one of those.
It may take you 5 or 6 years to afford it because it sounds like the price tag's going to be up there with a high-end gaming rig.
Yeah, that's what they keep doing. It's like, because I think the PS2 when it originally came out was like $150 or something like that, maybe $199, and then the PS4 when it came out I think was like $299. The PS5 I think was like $5 or $6, the low version. It's like everybody else. They're gonna throw some extra stuff, but they're gonna charge you more. We will not. We're going to charge you the same amount every time you come here. We are going to wrap this one up because we're going to ride off into the sunset or something like that and go have a good time. As always, feel free to like leave us notes in the comments. Check out the show notes. Those are like, we've got some AI stuff and stuff like that. We usually get really cool show notes, lots of links there. Check us out here. So you can check that out on the site at developreneur.com, or you can just leave some comments here and say, hey, dudes, can you send me something? And we'll shoot you an email of that episode stuff. Or we may throw other stuff at you. It depends, because we do have things floating around that we could send to you. Just a little teaser there, no promises, but you never know. You never know what might end up in your mail if you send us something, because we are very appreciative for you guys out there listening to us and being there and putting up with our ugly mugs for the last little bit of time that you did. That being said, we're not going to go get facial surgery, so you're still going to be able to see our same ugly mugs next time around. And you guys have a great day, and we will talk to you then.
Take care, everyone.
Whoop, that is not the button I want. There we go. Stop recording. I freaked out.